So the first thing I'm going to do is quickly write out the guidelines. Remember that acronym? It's dialects. Okay, so let's write it somewhere here so we can use this space fully. So it's going to be D-I-A-L-E-C-T-S, dialect. So this will be the first thing, and that represents the domain. The good thing about polynomials is that the domain of any polynomial is from negative infinity to positive infinity. No vertical asymptotes, no horizontal asymptotes. That's why I said it's easy. So D, domain is from negative infinity to infinity. See? The first task is complete. Let's go to the second one, the intercepts. Okay. Like I said, the most difficult part of this is for you getting the x-intercept, which would be the point where y is equal to 0, okay? That means you're going to have to find all the values of x when this function is equal to 0. So let's see the x-intercept. Well, we have to solve this, okay? We're going to say that x cubed plus x squared minus x minus 1 equals 0. Well, I'm going to factor this. It is called factoring by grouping, okay? I'm going to take out x squared from here, and I'm going to be left with x plus 1. Then I'm going to put these together. It's going to be x plus 1 equals 0. As you can see, I can take out x plus 1, and then I'll have x squared minus 1 equals 0. Now I can open this up, or let's just say I have x equals negative 1, or x squared equals 1. So x equals plus or minus 1. Okay, now, so what are the answers that I have? I have the x-intercepts to be when x equals, so I have x equals negative 1, actually twice. Or let me just write it out. X equals negative 1, x equals 1, and x equals negative 1. So this and this are the same, but when you get the same answer twice in a polynomial, you say it has a multiplicity of 2. If you do it 3 times, you call it a multiplicity of 3. So we can as well just say the only 2 intercepts we have are x equals negative 1 and x equals 1. Those are the 2 points of interest, because this is just a repetition. So just to help yourself, quickly go to your curve and mark those places, okay? X equals 1 and x equals negative 1. It means your curve, your polynomial, will touch the x-axis at those 2 points. Let's move on to the next thing. So now what are the x-intercepts? Therefore the x-intercepts are negative 1, 0. So we can now go here and say it's negative 1, 0 and 1, 0. Those are the 2 intercepts that you have. What about the y-intercept? What will be the y-intercept? Y-intercept. Okay, will be the point where x equals 0, okay? At any point here where x is 0, let's plug in 0 here. You're going to have 0 plus 0 minus 0 minus 1. So what's left is just negative 1. So the y-intercept is where x equals 0 and y equals negative 1. Where is that point on the curve? It's right here. So let's mark this point also. So the curve will have to go through this point. We're going to get a picture of it. Okay, we're done with the intercepts. Let's go to asymptotes. Well, you go here and you write asymptotes. Let me underline it so you know they're the major things we're looking for. None. Does not exist. I told you it's easy. What about L, the limit? Okay, now let's do L here. Limits. Since there are no asymptotes, we just need to look for limits as x goes to positive infinity or as x goes to negative infinity. Well, we know that all polynomials will just keep going to infinity. If you're going left, if you're going right, you want to show your work. If you want to show your work, you can just use this form, okay? And say that the limit as x goes to infinity of x plus 1 into x squared minus 1 will be, if you plug in x here, it's going to be infinity times infinity, which gives you infinity, okay? You can repeat the same thing the limit as x goes to negative infinity of x plus 1, x squared minus 1 will be equal to negative infinity, because you plug in negative infinity, well, to be negative infinity times infinity, because this will become positive, and then you get negative infinity. So just know generally they will go to infinity and not a certain number. Whether it's positive or negative infinity depends on the kind of curve you're working on, the kind of polynomial. Okay, so we're done with that. Okay, what's the next thing? We want to talk about the maximum and the minimum. Remember, I said that these three always go together. So before you work on your extrema, which is maximum and minimum, before you work on your concavity, before you work on the trends, which is the intervals of increase and decrease, you want to actually just quickly take symmetry out of the way, okay? So let's test for symmetry right now. So we're gonna say symmetry. Remember, symmetry is that you're going to change x into negative x and see if the function remains the same, or if the function actually changes into its complete opposite. Okay, so it means every sign has to change, otherwise it's not the complete opposite sign, which will make it odd. So let's test for symmetry. So what is f of negative x? That's how to test for it. You plug in negative x here, you're going to get negative x cubed. You plug in negative x here, you're going to still get plus x squared, because the square is going to change the sign to plus. If you plug in negative x here, this is going to become plus x, and this is negative 1. Okay, so we know that this has changed because this sign here has become negative. But if it was odd, if this changed to negative, this would have changed to negative 2, but it didn't change. So now we have a completely different function. Therefore, this function is neither even nor odd. Okay, if it was even, the two will be the same. If it was odd, all the signs will change. Now if it is neither even nor odd, you'll get an answer like this, where some signs change and some do not change, and that means it is neither even nor odd. So you can just write that it is neither even nor odd. Now, what does this mean? It means when you sketch your curve, the left-hand side will look different from the right-hand side. And no matter what you sketch, if you keep rotating it, you will never reproduce that picture unless you return it to the original position. That's what it means. Okay, let's now go to our differentiation. Okay, so at this point, we can differentiate so that we start getting what we need to do. So let's go to f prime of x. Okay, so for f prime of x, we're going to differentiate this function. What do we get? It's going to be 3x squared plus 2x minus 1. Okay, multiply 3 by negative 1, you get negative 3. What two numbers will you multiply to get negative 3, but when you add them, you get positive 2? I know the numbers. I'm going to change this to plus 3x minus x minus 1. Okay? Okay, and this is going to be equal to 3x into x plus 1 minus x plus 1. So this factors into 3x minus 1 and then x plus 1. Okay, so we've been able to factor this. Now we can solve it and find the values of x, for which the function is either 0 or undefined. So the first condition is, when is f prime of x equal to 0? Well, that will happen when you solve these two. X will have to be negative 1 or x has to be 1/3. Those are the two solutions to that. Okay, the two conditions for you to have f prime of x equal to 0 means if you equate this to 0, you get this. If you equate this to 0, you're going to get negative 1. And that's what you need to determine the regions of increase or the regions of decrease. Okay, I mean the intervals, which I call the trends. Okay, but the good thing about this, my acronym, is as you're solving for t, you're simultaneously solving for e, which is the extremes. That is the extrema, like we say in algebra and calculus, will be the maximum and the minimum. So how do we judge? Do your test. Pick the 2 points, negative 1 and 1/3. I'm going to put negative 1 here, and this is going to be 1/3. So what you want to do is ask yourself, what's happening to this function as you begin to go from negative infinity until you get to -1. Let's pick a number before -1. -2 is a good option. Plug in -2 here. This is going to be negative. This is going to give you a negative result, which is -7. And this is going to be -2. So negative times negative will be positive. Did you see that? So what you have here is a slope. Remember that this is the slope function. The slope is positive before you get to -1. Because at -1, it became 0. So the slope was positive. It was going this way. Now, what happens between -1 and 1/3? Well, I know there's a number here called 0. 0 is a very good number when you can use it. Let's plug in 0 here between -1 and 1/3 and see what's happening to the slope. If you plug in 0 here, you're going to get -1, +1. Negative times positive is negative. Oh, so the slope is actually slanting this way, so the slope goes this way. So you notice that the curve goes up and then starts going down. So this point, remember, it's where the slope change is going to be a maximum point. This is a maximum, a local maximum. Okay, it's a local maximum and it's at the point -1, 0. So when you sketch your curve, you want to note that this point -1, 0 is your local maximum. That's what you write in front of E. So for your E, you're going to say extrema, okay, you say max happens at -1, 0. Okay, so let's go back to the other part. What happens after you leave 1/3? What number is after 1/3 you can use for substitution? 1. Okay, that's another easy number. Plug in 1 into this function. This is going to be 3 minus 1, which is positive. And this is going to be 2. Everything is positive. So it means the slope from here goes forward. This means this is another turning point, which you call a local minimum. You see this point? Is a minimum point. Local. It is not the absolute minimum because you don't know. Remember, we're going to -infinity later. Okay, so at this point, your minimum happens when x is 1/3. What will y be when x is 1/3? Let's quickly compute that. So let's put 1/3 here. 1/3, let's solve it here quickly. So it's going to be 1/3 plus 1, 1/3 plus 1, multiplied by 1/3 squared, 1/3 squared minus 1. I tell you this is going to be 4/3 multiplied by, this is 1/9. 1/9 minus 9/9 is -8/9. Your answer is -32/27. That's your answer. So that's the point. -32/27. Where is that here? That's going to be 1 point something. Okay, 1/5 that's about 1.2 thereabout. So just look for about 1.2 on your graph. It should be somewhere here. Okay, but it happens when this is 1/3. 1/3 will be around here. So you can just try to locate this point. This is point 1/3. Okay, and this is the point -32/27. That's this point. Right there. That's your minimum point. And what's your maximum point? Is at 0 at this point. So there's only one thing remaining for you to sketch your curve, because now we have a complete picture of what you can see, that this is how the graph is going to look like. But we just don't know when things begin to bend. You know, when you're coming down this way, when does it turn? That's where concavity comes in, and that will be your C. So the trend is already done. But for you to get the complete point for this, it is good for you to state clearly what this interval is. So let us state it on this side. So I'm going to move my writing to this part of the curve, okay, of the graph, so I can use it to write the intervals of increase. So when you go here, you say intervals of increase is from negative infinity until you get to -1. Then you pause. Then you start again from 1/3 until you get to infinity. So your answer in this case is going to be negative infinity to -1. And then it starts again from 1/3 to infinity. Those are the regions where the curve is going to be going up. Now, when will the curve be going down? It's just between -1 and 1/3. And that's what you're going to write for the second part, okay? You're going to say intervals of decrease is going to be from -1 to 1/3. And that's it. So let's talk about concavity. And for you to do concavity, I'm going to write it here. Yeah, I'm trying to deal with space here, okay? So for concavity, you have to take the second derivative of the function. So you differentiate this again because you want to know how the rate of change is behaving. Okay, so now the concavity, we take the second derivative, which means that you have to do f prime prime of x. Well, f prime prime of x means you differentiate this, and that's going to be 6x plus 2. So you're going to get 6x plus 2. And at the critical point, remember, just like we did here, we have to equate it to 0. So f prime prime of x is equal to 0 when, what will x be? Well, you're going to have x will be equal to 2 over 6, which will be 1/3. If you equate this to 0, you're going to get x equals, oh, negative 1/3. Come on, it's negative 1 over 3. So the concavity of this curve, whether it's facing up or down, changes at negative 1/3. Let's go look for negative 1/3 on the curve. Negative 1/3 has to be somewhere here. Okay, this point is around this area that the concavity changes. What does it change from? Does it change from facing down to facing up, or facing up to facing down? We now need to do another test like we did here. Let's draw a line. So we have negative 1 over 3. What's happening to this before you get to negative 1/3? Let's pick a number that is less than negative 1/3. That would be negative 1. Always use good numbers. Negative 1. Plug in negative 1 here. You're going to have negative 6 plus 2, which still gives you negative 4, which is a negative result, which means that this part is negative, and anything negative means the curve is facing down. So the curve goes like this. What happens once you go past negative 1/3? Let's use 0. Plug in 0 here. You're going to get a positive number, positive 2. It means your curve is positive. It's a bowl full of positivity, like this. So now you see the shape of your curve, and the last thing we want to do is just to sketch it, because we have a complete picture of what's going on. You see, this actually justifies this, and this part justifies this part. And we know the maximum point. We already got all those numbers together, and we know the intercepts too. So let's sketch it. The maximum point is, where is it? Negative 1, 0. So this is a maximum point. Okay, so our curve goes this way. We don't care about that part. And then what happens here? What happens is the concavity faces down until it gets to this point. Where is that point? Negative 1/3. Okay? Once it gets to negative 1/3, the concavity changes to face up. Ooh, like that. That's tough to sketch though, but I got it. Like that. And then it must go through this point because that's the intercept, and this is the minimum value. And then it goes back up and goes through this point and goes into positive infinity. If you learned something in this video, at any point, give it a thumbs up, give it a share, give it a like. Leave a comment in the comment section because it helps the YouTube algorithm so they recommend the video to other people. You'll be doing me a favor and I'm asking for it. Do it. Thank you. I'll see you in the next video. Until then, don't stop learning, because those who stop learning have stopped living. Bye-bye. remember to write the intervals of concavity, okay? When it faces up or down, you just need to write it under this. Make sure you write these things out before you start your work. Okay, so this is going to be from, it concaves upwards from -1/3 to infinity. And it concaves downwards from -infinity to -1/3. And that's it. Then you sketch your curve. Remember that.